Hello everyone, welcome to this video. In this video we are going to see different kind of solutions of differential equation. These are basically of three kinds: general solution, particular solution and singular solutions. So previously we saw that solutions are categorized into explicit as well as implicit. Now there is another category of classification. This is what it is based on how we obtain the solution. If we obtain, let's have a look into more detail about these three kind of solutions. So you already know that the nth order ordinary differential equation that is given like this: a0x dny by dxn, where this a0x, a1x up to a and x, they are all functions of x. Also, right, b of x is also constant function of x, right, and these are the n derivatives. Here a0x should not be identically equal to 0. Why? Because otherwise your equation won't remain nth order. That you already know. And you can also express this differential equation of yours into a function form where it is a function of x, the independent variable, y, the dependent variable, and all the derivatives up to nth order of this dependent variable y with respect to the independent variable x. Correct? Now, using this thing, we can now define different types of solutions for this differential equation. So let's first have a look at the definitions here. General solution is a one which contains n. If we have equation of nth order, then in that case we would have n independent arbitrary constants present in the solution. So when you solve this, if you have a second order differential equation, ordinary differential equation, then in its solution you would have two constants, and the constants can take any value. Now what does it mean to be arbitrary? Arbitrary means they can take any value, right? It is not restricted that they should take certain particular values. They can take any values. And what does this term independent means? It means that one solution cannot be expressed in the other form. One constant cannot be expressed in terms of others. Then it is independent. Correct? So general solution which contains as many constant as the degree, as the order of the differential equation. And what is a particular solution? This particular solution is obtained from the general solution, right, when we assign certain values to these constants. Correct? So that is particular solution. And what is singular solution? Singular solution is a solution of the differential equation which cannot be obtained from the general solution. This cannot be obtained from the general solution, right? So you would be knowing about these three kind of solutions once you see the examples. So let's move forward and have a look at the examples. Correct? So here our first example is a second order ordinary differential equation, which is y double dash, which means the second derivative of y. This is the prime notation, double dash representing the derivatives, right? Minus 3y dash plus 2y. Y dash is first derivative and y as such. This is your differential equation. Now I say this is y is equal to c1 e to the power x plus c2 e to the power 2x is a solution of this differential equation, right? Now where what is c1 and c2? They are the arbitrary constants that we were talking about, right? They are independent and they are arbitrary in nature. Why? Because one is not dependent on the other. They can take any values, right? Now because our equation was of second order, so we have two constants present here. Now I say you first of all verify whether it is a solution to this differential equation or not. So how do we do that? We just calculate the values of the first derivative and second derivative from the given curve y, and then substitute all the values here into this differential equation and see whether this differential equation is satisfied by this function y, y dash and y double dash or not. If yes, then it is a solution. If not, then it is not a solution. So let's verify this thing here. So we can very easily compute the derivatives of this function. c1 is constant, so derivative of e to the power x is e to the power x. Correct? And here C2 is constant, so it will be as such. Derivative of e to the power 2x would be e to the power 2x, and then the derivative of 2x, which would be 2. So you would have 2c2 e to the power 2x. And what would be the derivative of this again? So it would be c1 e to the power x as such, and it would be 4c2 e to the power 2x. You can verify this thing. So now once you obtain the first derivative, second derivative, and the value of y, you can substitute all these values in the left hand side of your given differential equation. So substituting the value of y double dash, y dash, and y here, and then taking the terms which are common. So you see c1 e to the power x is appearing 3 times here, so we can list the coefficients as 1, -3, and +2 here, correct? So once you solve this, you see that this is equal to 0. You solve this quantity, it becomes equal to 0. Similarly, for the second term, c2 e to the power 2x is appearing in these 3 terms, correct? So you can collect the coefficients. For is -3 plus into 2 is -6, and then +2 is +2. You can add all of them to obtain 0 again. So you see this is equal to 0, and 0 was the right hand side of the second equation. Hence this becomes the solution. And what kind of solution it is? It is a general solution. Why? Because it contains 2 arbitrary constants present here. Correct. Why it is a general solution? Because it has c1 and c2 as 2 arbitrary constants present here. Now can I give you a particular solution of this differential equation? Yes, I can. Here you see, if you substitute the value of c1 as 1, you can take any values, c2 as 1, then your solution, it would be e to the power x plus e to the power 2x. So this is our particular solution. So you can also verify that this solution also satisfies your differential equation. So this is a particular solution of our differential equation. Similarly, if you take the value of c1 as 1, c2 as -2, some other values you can also take. So this is also another particular solution of 2. So can we say there are infinite numbers of particular solution to our given differential equation? Yes. Why? Because we can take infinite number of values, or there are infinite number of choices for the arbitrary constants which are present in the general solution, correct? So this is about the general solution and particular solution. Now let's move forward and look at another example to have more insight into the concept. So we consider another differential equation which is of first order, right, and second degree. So we have to first of all verify that y is equal to x plus c whole square. That is a solution of this differential equation, and I say it is a general solution. So here you see, here the order of the differential equation is 1, so we have one constant here which is c, correct? So let's first of all verify that it is a solution to this differential equation. For that, we calculate the first derivative here and substitute it in our equation, this differential equation. So once you substitute in the left hand side the values of the first derivative and y, and then simplify, you get to see that you obtain the right hand side, which is again 0, correct? So therefore it becomes the solution of your differential equation. This is your right hand side, hence it satisfies your differential equation, hence this is a solution, and it is a general solution. Now can you see another solution for this differential equation? Yes. If you take y to be 0, here you will have 0. And what would be the derivative of 0? That would again be 0. So this term is also 0. So you see 0 minus 0 is 0. So it also satisfies your differential equation. So y is equal to 0 is again a solution, right? In fact, if you take c is equal to 1 here, you obtain y is equal to x plus c. If you take c is equal to 1, so you get x plus 1 whole square. This is also a solution. And what is this? This is a particular solution to your differential equation. Now, as I mentioned, if you take y is equal to 0, right, this is also a solution of this differential equation because it satisfies the differential equation. However, this y is equal to 0 solution cannot be obtained by any choice of c in your general solution y is equal to x plus c whole square. Therefore, y is equal to 0 is now a singular solution of this equation. Why? Because it cannot be obtained from the general solution, right? So I hope you understood this concept of general, particular and singular solutions well. Well, that is it for this video. Thank you for watching.